This meeting is.
Okay, guys. Welcome to January 2024 course networking. This course is about CCNA, Cisco Certified Network Associate training. So this will help you to understand the network fundamentals, and it will give you like networking 101 classes to understand what is networking and what are the various technologies involved to succeed in the networking engineering job. This is not a certificate course. This is more of like an, my goal is to get everyone understand about the terminologies in networking and also the basic concept learning by which you will be able to understand at least the fundamentals of networking. That is what the goal for the course is. So this will be more of like introduction class. So I will just give you a demo on what is networking, why it is used, and in this course, what are the topics that we're going to cover. And we will start talking about, a one-liner about each topic that we're going to discuss in this course. Okay. So this is a 40-day course, 40 to 45-day course. We will talk various topics as per the certification curriculum. So let me start sharing my screen and then show you what do we discuss on and what is our agenda for these courses. Yeah, so.
Sir?
Yes.
Sorry for interrupting, but there is a guy called Monish. He's waiting in the waiting room in the Zoom call. If you don't mind, can you just let him in?
Yeah, I did.
Thank you.
Okay, so in the week one, we will discuss about basic network topologies. How does and what is the basic network networking concepts. On day two, we will talk about what is the OSI layer model and what is a TCP/IP model. These models are nothing but to troubleshoot a network problem, to troubleshoot a network issue. This model will help us to identify the problem. So we will discuss about the 7 layers of OSI model and 4 layers of TCP/IP model. That's what we'll discuss in the day 2. And then we will discuss about IP addressing, subnetting. And even before that, we'll discuss about layer 2 concepts like switching, fundamentals of switching, how do we interconnect between the systems and all. So let's take a step back. Let's look at what is networking. Why do we need it? Why do we need networking in the first place? What are the use cases of networking? We will discuss about them, and then we can start looking into the agenda of the course. So let me start sharing my whiteboard. So let's say you have a PC and you have another PC. It can be a laptop or a PC. So this is PC 1 and this is PC 2. So this PC will have an IP address. IP address is nothing but a address that is given for a device to make it communicate inside the network, right? So IP address is a naming convention that is given to a specific device so that to identify the device in the network, and with that IP, with that identification number, we should be able to communicate to that IP address. So let's say this IP address of the PC1 is 1.1.1.1, and the IP address of PC2 is 2.2.2.2. And if this PC1 wants to talk to PC2, right? So the communication between PC1 and PC2 is nothing but networking. So networking is nothing but making two devices communicate so that they can exchange the information. That is nothing but networking. But inside that, these pieces can be in two different locations, or these pieces can be in the same location, or this PC can be located in different country, right? So depends on the geographical separation of the devices between the source and destination. So in this case, PC1 is the source because it is trying to start the communication, and PC2 is the destination because it is trying to get the information from the source, right? So here in this case, PC1 is called source. And the PC2 is called destination. Why? Because PC1 is where the connection is being started from, and PC2 is where the connection is being received to. So the communication between PC1 and PC2 is called networking. And also, when you send an email or when you send a mail to a destination place, you will write from address and to address for your packet to go and reach the destination, right? Similarly, here, the source address for that device is 1.1.1.1. And the destination for the PC2 to reach the packet or that letter to the device is called destination. So just like you have sender and receiver in mails, we have source and destination in the network terminology. Source is the one who is initiating the connection, and receiver is the one who is receiving the connection from the source. Okay. So this is about like the basic networking. Now let's see a use case on a regular network that is used on a daily basis. Any questions so far?
No, sir.
Okay. So I took a small home network. So inside that home network, we have a router, the service provider like AT&T or Spectrum or third-party routers which support the internet, which provide the internet connection. They will come to our house and install this router. In this case, I'm taking Spectrum router. These are inside the house. Right. The PC1 is inside the house, it is connected to the router, and the router is sending the Wi-Fi signals, right? So this router is sending the Wi-Fi signal inside your house, and the PC1 is catching that Wi-Fi signal, and you are putting the username and password to connect to the Wi-Fi. So the PC1 will be wirelessly connected to the router, and the router will be connected to the service provider. For example, if you're using Spectrum, the Spectrum will be connected to your wall mount, and the wall mount will be connected to the service provider connection. It may be end of the street or end of the community. Like all the houses will be connected to this one, and from here they'll let you talk to the internet. So this is how a single home look like, right? So as a network engineer, you have to make sure that whether your PC1 is able to log into the SSID or not, whether this router has the connection to the service provider or not, and whether the connection is reaching all the way to the internet and coming back to the PC1 or not. So if you are not a network engineer in a regular house, if there is any issue, the maximum thing that you will do is you are rebooting the router. But you are not the one who will be troubleshooting the router issue, like by logging to the router, by validating what is the issue on the router, by checking the logs on the router. You will not do that because you are not a network engineer, but you are an end user who is using this PC. So you can reload this device, like reboot this PC, and you can also reboot this router. Like your Wi-Fi router in the home, you will restrict the router. And those are the two things that you will try, but you will never do bigger troubleshooting or deeper troubleshooting on what might be the issue, because the user is not able to reach out to the internet, right? So in this course, we will discuss about what could be that issue. Is it like an interface level issue, like a physical layer issue? Is it like a switching issue? Is it like a routing issue? Is it like a port issue? So we will discuss everything and make sure that we get the fundamentals right as per the network topologies connectivity. So you as a network engineer, on a daily basis, depends on your network that you fix. You understand what could be the problem, and then you will provide a rectification to the problem by troubleshooting and fixing that issue. Okay. Any questions so far? Any questions, guys?
No.
No.
No, sir. No.
Okay, so now you understood what is a network, and what will be the responsibilities of an engineer to fix if there is any issue in the network, right? So now let's talk about what are the fundamental topics that need to be discussed to get the connection going on. So let's talk about the fundamentals of the basic devices. So this is PC1 and PC2. These are the two personal computers that are out there, and we wanted to make them communicate between them. So these are two in the same location, and they are in the same network, meaning they are like in the same network size, which they should be able to communicate, right? So if two devices need to be communicated, they should be in the same network by default. If not, the communication will not work until we put a layer 3 device. But let's take a step back there and then see how does the two PCs communicate, right? So this is PC1 and PC2, and these two PCs will be connected to a device called switch. Right, so we have PC1 and we have PC2. Now PC1 needs to talk to PC2, that is the end goal, right? But they are in the same network, meaning they should be able to reach because of the IP address that we gave. Remember, I talked about IP addresses at the beginning. IP address is nothing but the identification of the device, but at the network layer. As a network engineer, you only care about IP addresses, not the devices underneath it. Okay, so now PC1 to talk to PC2, they should do a lookup of the PC2, meaning PC1 should do a lookup on the PC2. So that is called a broadcast message. So let's say the IP address of PC1 is 1.1.1.1. Okay, PC1 is 1.1.1.1, PC2 is 1.1.1.2, right? So the PC1 will have an IP address 1.1.1.1 and PC2 has an IP address of 1.1.1.2. That is, you as an engineer, you assigned an IP address to the switch PC, right? But when this PC is manufactured, there will be a MAC address. MAC address is nothing but the hard-coded address that is given by the company itself. If you go and purchase a laptop, your laptop will have a MAC address by default that is defined by the vendor itself. Let's say you go to Best Buy and you buy a laptop, like maybe HP laptop, it will be having a serial number and also a MAC address. It's a hard-coded address based on the company. When they manufacture the company, when they manufacture from a company, they will put a MAC address which is unique in the world, right? So that this can be identified in any layer 2 network. Okay, so let's say the MAC address of PC1 is there are two PCs and there are two MAC addresses. So because they are in the same network, meaning if they are in the same physical location, right, they are in the same local area, then these two should be able to communicate using the MAC addresses. They don't need any IP address. I mean, because we are not doing any inter-network communication, we are not making two networks communicate. We just need a layer 2 MAC address to communicate between them. Okay, so let's not get confused with what is a layer 2, what is a layer 3. These are all the terms. When we discuss more on the OSI layer model, you will get more clarity on what is a layer 2, what is a layer 3. So don't worry about when I meant a layer 2, don't think that you're not understanding the concept, but just think like layer 2 is nothing but a switching layer where it will be able to communicate two devices inside the same network. Okay. So when it comes to layer 3 is nothing but when there are in two different networks, we should be having a router to make them communicate. For example, here, let's say this IP address of this PC2 is. So 1.1.1.1.1 is in different network than 2.2.2.2.2, right? So they are in two different networks. Now, these cannot be able to communicate with the MAC addresses. Now we should be having a router. So because these are in two different networks, to communicate between PC1 to PC2, it has to go to all the way to the router and come back and talk to the PC2. So for PC1 to talk to PC2, it has to go through the router, and the router will make two networks communicate between them. That's because of they're in two different networks. We need a router to make them communicate. So again, I repeat, when two devices are in the same local area, which is called as local area network, and if they're in the same network sizes, two PCs will be able to communicate using the layer 2 with a switch. But when we are talking about communication between two different networks, altogether we have two separate entities, and if they wanted to talk between them, that is called router, and router will be able to communicate the layer 3 communication with one network to other network. That can be done only with the router. Okay, let me give a practical example to understand more. So I took two regions here. One is US region and other one is UK region. Now I have two, let's say I have 2 or 3 devices inside that region. So let's keep network terminologies aside now for a second. So if I wanted to make, let's say this PC or this device, if it wants to make a call to this device inside the same US area, it does not need any international dialing. It will just use a local phone number with a +1 code, and then it will make that call. But if someone in US, if they want to make call to someone in UK, they have to enter a +44 code, because they're going in a different route, I mean to a different region with a different area code, right? So they have to go to the router will route them back to that code, right? So, but if someone wants to talk inside the same region, or if someone talk to same inside the same region, there is no issue. They can be able to communicate without any extra router in play, right? So similarly, if I'm taking two PCs, if they're in the same network, think about like they're in the same USA, then I just need a switch to communicate between them, between two PCs in the same region. But if this PC wants to talk to something in a different region or in a different network, I need to have a router in picture. So communicating two devices within the same network will be done by switch, but communicating two devices within two different networks will be done by router. Is that clear, guys?
So
Yes, sir.
like you're saying that layer 2 will help you communicate using MAC address using the same network by using a switch, but layer 3 will help you communicate using IP address using different to talk with like different network using a router?
Yeah, you got it right. That is picture for perfect.
Thank you.
What do you mean by switch in real-time scenario? Is it a device or something?
Yeah, switch is a device and router is a device. Yes.
Okay. Can you tell me an example for a switch? Like is it a optic fiber cable or LAN cable or something?
Well, optic fiber cable is you are connecting two devices with like long distances or high throughputs, right?
Yeah.
So, but we're talking about a switch, just like think about like an adapter, right? You want to connect something to the, or I would say like extension box. You will have one socket in your door knock. You will put one extension box. You will increase number of ports, but you will have more number of charge points, right? Similarly, a switch will make two or three devices communicate by having that communication between them. So one of the example that I can give is like Cisco 2960 or Cisco 3750. So you can Google that names. You'll find how does a switch look like, or I can just show you how it looks like. Hold on. Let me
Okay.
stop. Yeah,
Thank you.
share my screen. Yeah, a switch looks like this, where you will have these many number of ports, and you can plug in your PCs to that port, and then you can make them communicate. And there is a way, I mean, with the MAC address, the switch will maintain the database of all MAC addresses and make them communicate. And the slots where you plug in your, am I sharing?
No.
Oh,
No.
sorry. Okay. And now I think I'm sharing now. Okay, so can you see my screen?
Yeah.
Yes, sir.
So this is how a switch will look like. And these ports is where you plug in your laptops, PCs, or any endpoints, you plug in those to those ports. And this switch will maintain a MAC address table based on the port number. It will maintain the MAC address of all the devices and it will make them communicate. We'll talk more about that. How does it work when we talk about broadcasting and maintaining a CAM table. Okay, but this is how a switch will look like. A physical switch will look like this.
Okay.
So there is that. And so now you understood what is networking and how does the communication takes place inside the same network by using a switch, and outside the network between two different networks, it needs a router to communicate between them. Right? Okay. Next, we'll talk about, a different use case where why do we need networking? Okay, so I'm going to take example of the office space. And here in this office space, let's say we have let's say we took a building and then it has like 4 floors or 5 floors. Inside that each floor, there are like, this is, let's say this is floor 1. Floor 2, floor 3. So I took a building, an office space. Inside that I have 5 floors. So inside each floor, let's say I have PCs. In some floors, I have printers. I have iPads, laptops, various devices that are used by the end users, right? So now each floor will have a switch. So this floor will have a switch, this floor will have a switch, this floor will have a switch, and this floor will have a switch, and this floor will have a switch. So how does this look like? Like every floor will have a floor switch that is called access layer switch. So every floor will have access layer switch so that inside the floor, if one user wants to talk to the other user, they will be using that access layer switch to communicate between them. Okay. And we will also have some distribution switches. Distribution switch 1 and distribution switch 2, where each access layer switch will be connected to. Okay. So this is called a highly converged architecture because so every floor will have its own switch to communicate between the devices inside the same floor. Okay. But if one floor wants to talk to other floor, so if let's say floor 5 wants to talk to floor 1, floor 5 device will go to floor 5 switch, floor 5 switch 1. I got the numbering wrong. Okay, anyways, it will go to the access layer switch 1. It will go to the distribution switch 1. And then it comes back to the AS switch 5. And then it goes to this device. So this is called a tier architecture. This is called tier 1. And this is called tier 2. Or it's called tier 0 or tier 1. Depends, right? It's like ground floor and first floor, or first floor and second floor. Similar concept. Right, so it's a tier 0 and it's a tier 1. So if any PC wants to talk to the other PC inside the same floor, it will be talk to the access switch and then come back and talk to the same floor device. But if floor 1 wants to talk to floor 5, then it has to go to this access switch. It will be pointed to the distribution switch, and the distribution switch will be pointed to this floor 1. So you as a network engineer, your responsibility is to make sure your devices are connected properly to the access layer switch, and the access layer switch will be connecting to the distribution switch, and the distribution switch will be connected to the other layer access switch on the other floor, and that will be connected to the endpoint. So our responsibility as a network engineer, if you're working in an office location, you should be making sure this connectivity works as per the plan. any device in any floor will be able to communicate with any other device in any other floor by having the correct connectivity between them. So you should be able to, after this course, you should be in a place where you should be make that happen in terms of communication between devices inside the same floor or different floors. Okay, that is one more use case that we should be able to solve after doing this course. Is that clear, guys? Any questions with this topology?
Yes, sir.
So
Yeah, what
our
is the question?
responsibility go on.
Okay, sir. So how the signal will be decided whether it will be goes to device switch 1 or 2? When it goes for access layer switch, it has to be travel to DSW1 or DSW2. So how it will be decided? All the ASWs will be, yeah.
Based on the protocol that will be decided. It can be called as HSRP, hot standby routing protocol, or virtual redundancy routing protocol, or gateway load balancing protocol. So you have 3 protocols to choose which one to
Okay.
choose.
Okay, perfect.
Okay, what is the next question?
So in here, our responsibility is just to make sure that everyone is everyone is just able to communicate with every other one.
That is one use case, yes. There might be hundreds of other responsibilities, but it is one of the top responsibility.
Okay.
So the main priority will be the communication, whether
Yes.
the communication reaching or not. If not reaches, why? If reaches, how?
Yeah, that is the responsibility of a network engineer. That is what we are trying to achieve here in this course,
Okay.
in your role. The
Okay.
major responsibility is the communication.
Okay. So, sir, I just have a one query. Like taking as the same example in the floor, like 4 floors, how many network engineers will be taking access? Just a scenario. Like for each floor, there will be one network engineer for entire project, like for entire building.
For 50 buildings, there will be one engineer.
Okay, perfect. Thank you, sir.
Any other questions, guys?
No, sir.
Okay. So
Sir,
the other
is there any like source you will be providing to us, or just only the virtual class sessions? Like for if you need to recheck the video or any documents, any notes will you provide to us?
Yeah, we will share the recordings in the spreadsheet, and we'll also do assignments every week. We'll
Oh,
also
sure.
give the outside materials like Route Alley, where you can go through.
Okay.
And also, you can go through my blog.
Oh, okay.
I have written all the content in my blogs. I'll also
Okay.
share my blog where you can take a look. I'll share that here in a minute.
Okay, sir. Thank you.
Yeah, hi sir. Are all these connections are physical connections? Are they or they are connected through Wi-Fi? Are they wireless?
Access layer wise, the first connection can be wireless, but when you're dealing like between like buildings, the Wi-Fi signal cannot be traveled. You know that already, right? When you're using Wi-Fi, the Wi-Fi has a limited range. It cannot go beyond that point. So you cannot connect buildings just using the Wi-Fi. But inside the building, you can use access point and you can use Wi-Fi as a connection. But other than that, it's all wired.
Okay.
Yeah. Thank you, sir.
Sir, in that case, like all the systems, like PCs, tablets, laptops, there is a case only with the signal or maybe the wires to the access layer. Maybe
Both.
signals or maybe wires or only
Both.
signals, like
Both.
Wi-Fi. Oh, okay. Okay.
Sir,
Go ahead.
so you said that there will be a limited range for the Wi-Fi, like which is restricted to a particular building. Like my university is really big, it's really large. Then how come we have the same Wi-Fi everywhere in the entire university? Like
Because they're using access points everywhere. They are broadcasting that same access point. They are broadcasting same SSID everywhere. With one access point, it is not possible, right? Let's say your university has like 20 buildings. In 20 buildings, you will have access points everywhere. You just think about like a small target space. If you look about your head, you will be seeing access points everywhere in the target store. That means that one access point is not sufficient for the entire floor. They will use multiple access points.
okay.
Similarly, in your university, even though you are seeing it as a one Wi-Fi, but they are using multiple access points, and there is a device called WLC, wireless LAN controller, which is managing all of these access points.
Yeah, with the same configurations, right, sir?
Same configuration, yes.
Okay. Like same like using a YouTube or social media on multiple tablets, like multiple devices with the same user ID and password. Like same scenario?
I would say it's like
Not
one
exactly,
master,
but similar. Yeah.
one master, lot of slaves. Okay, you will
Yeah,
have one
yeah.
master controller that is maintaining the configuration for all the slaves. So you will push the configuration from that controller or from that master to all the devices. So it's like a replica of the devices.
Maybe like a signal booster, like Wi-Fi router, signal booster type of thing.
Signal booster is like a repeater. You send a signal that will extend that signal. But we are not talking about the signal here. We are talking about the configuration part. See, let's say in your house, you will have access point, right? So your access point is limited to your house. But what if your house and your neighbor house will have the same SSID and same password? Then we will put a controller to manage both the houses.
Okay, so the network provider will be responsible for that. Like same taking example as T-Mobile. So in the same scenario, in my house, we have like around in my community, we have like 4 Wi-Fis in the same person name. All the person use the same Wi-Fi, they maybe pay more, but they get the user ID and password as same in the same scenario, yes, sir?
It could be, but what I'm trying to say is you are pushing the same configuration everywhere so that it keeps identical, so that the students in the university does not have to worry about connecting different SSIDs. They will try to make it identical everywhere inside the university.
Yes, sir.
Okay, I'm gonna stop there. I will share few resources that you can use. Let me. You go to CCIE-journals.com. So this will take you to my blog. This is about me. And then if you click on CCNA concepts, you will get here the labels of CCNA concepts. You can click on here, or you can, let's say you wanted to learn about, like maybe VLAN. Okay. You'll get a page about VLAN. What is a VLAN? What are the benefits of VLAN? You will get some theory. Let's say you wanted to learn about earlier someone is asking about whether to choose DS1 or DS2, right? So if you want to learn about HSRP, so you will search HSRP there, and you'll get a page about HSRP, and you'll get like, how do we use HSRP in the real time? What are the concepts there, like that. Let's say you wanted to learn about OSPF, other routing protocol. So you can click on OSPF. You will get what is OSPF and how it is used and all of that. So I recommend going through the CCNA concepts. For example, after completing our session, okay, let's say tomorrow we talk about OSI layer model, right? So you come here and then you click on OSI layers. This will give you more context of what is OSI layer model and what is little bit more detail about each layer, and then some interview questions about OSI layer model, like that you will see. So after completing our class, if you come over here and then search for the topic, you will get some context. You can use that. That is one use case. And also you can go through other blog called Route Alley, one of my favorite websites for the entry level guys. So here, if you can click on Route Alley guides, you will see topics. For example, if you want to reference the OSI model, you will click on OSI reference model. It will give you a small PDF that talks about OSI model in detail. So you can read about OSI layer model, each layer here. So this will also give you a context in detail about the topic. So these are the top two resources that you will use in this course. And for labs, you will use Packet Tracer, where you will do the labs. I will do the labs in the class, and then you will replicate that labs. I will also give you some lab scenarios to execute and test. But for labs, we'll use a tool called Packet Tracer. Packet Tracer is the network topology tool that we will use to make the lab connections and then test it out. So it's a Cisco free based tool. And also I will share you the link how to download that to your Windows or MacBook. Okay. So this is how the the core components work in this course. So you will come to the class. We will talk about a topic or two within our 1 hour time frame. We will try to do the lab on the next day, and you will also read some stuff. And by weekend, like Friday evening, I'm going to give you the test, and then you have to complete that over the weekend and come back. So this will be the workflow.
Sir, so the session is not going to be on Saturday or Sunday, right?
No, only on the weekdays.
Yeah, when I just go to the schedule, I just noticed that like 28, 29, 30, 31, 1, 2, like all the dates like this.
Zoom does not give the weekdays, so we just put a recurrence right there. That's why it's showing there, but it's only on the weekdays, Monday to Friday. No Saturdays.
Okay.
It's left for the practice and the labs.
Yeah, and like how we could gonna find like the same recorded sessions or what you are teaching to us? We will be posting in the group.
Once the recording is done, there will be a spreadsheet. That spreadsheet will be in the group. In that, there will be a tab called recordings. That recordings will be there in that.
Okay, perfect. Thank you.
Okay, so that is about the introduction of the class.
Ravi sir, I just have a query. Like, is there any specific portal could you show us right now, like for a CCNA exam application or something, like to book a slot? Like whatever we are going through training right now. I think there should be a
portal
specific
is called
website.
the portal is called Pearson View. So if you go to Pearson View, you can book a slot.
Yes. Okay.
Here, if you can go here, and then you can click on login. You have to create username and password. I don't want to log in with my credentials now, but that's how you will go ahead and book the slot. Okay, any other questions? All right, guys. Thank you for joining today. We will be talking tomorrow. We'll talk about OSI layer models, 7 layers, and then we'll talk about how it is used in networking. Thank you for joining today. We'll see you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
ఇలా మనకేమో కనీసం $10 కన్నా ఏమో ఫుడ్ అలా దొరుకుతుందేమో కానీ ఇండియాలో అయితే ఏం లేదు రెస్టారెంట్